Factor the expression 9g cubed h minus 16gh cubed. Okay, so this is just an innocent, hey, let's factor this. What can we do? Well, it's not a quadratic sort of thing. I don't see x squared. I mean, traditionally it's x, but, you know, we could be looking for m squareds or anything like that. But, well, what do I notice? It's just a nice, innocent little difference. Now, when it comes to factoring, there's sort of two layers to factoring. You can say, what do all these terms that I'm adding or subtracting have in common? And then you can go in for the more in-depth sort of, oh, this is a special sort of formula, this is a common expression, and we factor it like this, or, oh, I'm going to, you know, find two numbers that multiply to this and add to this. So the first thing I would do is I would ask, is there anything these numbers or just factors in general have in common? Right? Because if I saw something like 3a plus 6b, I might say, hey, 3 and 6 are both multiples of 3, so I could take out at least a common factor of 3. That's something that could be said there. Okay? Now, 9 and 16, well, they don't have anything in common. So, okay, no numbers. But let's think for a moment what we've got here. G cubed h. So that's g times g times g times h. And then we've got 16g h cubed. So that's h times h times h. And sometimes when you write it out like this, you might say, well, hey, each of these has a g and an h. Sure, one of them has a few more g's, the other one has a few more h's, but they have a g and an h in common. So maybe we could factor out a g and an h. Okay, just remove them from what we've got, and then what do we have left over? 9 and then 2 g's, I'm just going to call it g squared, minus 16, and then I've got 2 h's. I call it h squared. Okay? So that's definitely something we could do. Take out a factor of g and a factor of h because every single term here has a g and an h. Some of them have more g's, some of them have less g's, but they each have at least a g and an h. Okay, so there's a g, there's an h, and then this. Can I factor it any more? Well, we've actually run into something like this before. I might notice that 9 and 16 aren't just your average numbers. 9 is 3 squared. 16 is 4 squared. I've got a bunch of squares lying around. Okay? And we know, we've seen this, we know our exponent rules. We know a times b to the power c can be written as a to the c times b to the c. And so if I recognize, say, 3 squared times g squared, I could write that as a single square, just going the other way. So I could write this as 3g squared minus, and then 4h squared. And then what's this? A difference of squares. And that's something special that can be factored. All right, so we're just going to factor our difference of squares here. Okay, if you don't remember what difference of squares is, I'll just write the general rule. Some expression squared minus some other thing squared can always be factored like this. It's one of the most common sort of factorings besides just generic quadratic formula, quadratic factoring. Okay? So 3g minus 4h times, and then we add them, 3g plus the 4h. Right, and there we go. And that's the whole thing factored there. Okay? So we did manage to see sort of the two layers when it comes to factoring, taking out things that are quite obvious and common, the g and the h, but then recognizing an expression or applying a technique that we know, in this case, difference of squares.